to another video of our SD-WAN training. I hope you all are doing good, and let's get started with it. So in the previous video, we discussed about the control plane that comes along with the SD-WAN solution. And I suggested that we'll be discussing about the last component of our SD-WAN fabric, that is orchestration plane, in the next video. So let's get started with that. So the orchestration plane is kind of a new plane that we see.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
Apart from the traditional planes which are available in the traditional network, like control plane, data plane, and management plane. So over here we have orchestration plane that is available to us, and the component that takes care of orchestration plane in the SD-WAN is VBond. VBond uses the same image or operating system as of VH or CH. That's why you can deploy your WAN edge and make it act as a VBond also. There is not going to be any separate component or separate operating system for a VBond. It is going to be the same as of your WAN edge. So you can deploy VBond both in physical mode as well as in virtual mode. If you use a physical router and make it act as a VBond, that's going to be a physical VBond. If you make a virtual operating system of a router or a WAN edge act as a VBond, that's going to be a virtual VBond, right? But it's probably the most important component in the Cisco's SD-WAN solution, right? This component is basically so important because it provides the initial authentication to the WAN edges for participating into the SD-WAN fabric. Okay, so multiple VBond servers can be deployed to achieve high availability. And although a WAN edge can point to only a single VBond, but it is recommended to have the WAN edge use the DNS addresses in order to reach out to the VBond, because there can be multiple VBonds deployed, and that particular VBond can or the list of VBond can be provided to the WAN edges. So how does it generally works? Let's speak about that. So if I draw a topology that explains you the architecture and working of VBond, let's think about it. So we have a set of SD-WAN controllers where we have a vManager, then we have a vSmart, and we also have a VBond, and I will call it as, come on, the SD-WAN controllers. There is definitely going to be an admin machine that connects to the vManager, and the vManager and vSmart are also connected to each other. Right, this way. Then there is the ISP connectivity. So the ISP can provide you the iNet connectivity. Then we have MPLS connectivity, and then we also might have 3G or LTE connectivity. Right. Post that, we might also have the WAN edges. So let's say right now we only have a single WAN edge. I'll call that as WAN edge number 1, and that particular WAN edge gets connected to the ISP by using either of the mediums. It can be connected via iNet, it can be connected via MPLS, or it can be connected via the cellular services. So this is kind of the architecture that you have. Once you have this architecture, now there is a public portal which is available. So when a WAN edge first joins the overlay network, the only thing that it knows about is the VBond IP address or the VBond details. And how do you let your WAN edge know about that information? There are two ways to provide VBond info to WAN edge. Number one, you can do that by using plug and play method. That is also called as PNP. And the second method which we are discussing about is the manual method. There are others also, which is to configure a bootstrap config or do zero touch provisioning, which is also now merged into PNP. Earlier, there were two methods, plug and play and then ZTP, zero touch provisioning. The PNP would work for Cisco's WAN edges and ZTP would work for Viptela WAN edges. But now it's all PNP only. So let's say the SD-WAN controller fabric uses the prefix 223.1.1.0/24, out of which the vManager has .10, the vSmart has .11, and VBond has .12. So what you do is you configure an IP address onto the VBond that is 223.1.1.12. You can also map that particular IP to a DNS, right? And you can say that's vbond.organizationa.com, right? And there can be multiple vBonds, all of them can be pointed towards it. So if you have a DNS address, you can configure that DNS address onto the WAN edge system settings, right? Or if you do not have a DNS address, then you can configure the IP address of the VBond manually onto the WAN edge. That's manual method. The other method is plug and play. So Cisco maintains something called plug and play portal. Or I would call it as PNP portal. That is available publicly on software.cisco.com. Okay, and you need a smart account, Cisco smart account, to sign in into this particular portal. Once you sign in, inside of that portal, you need to create organization profile. And in that organization profile, you will define certain things. You will define organization name. You will also define the VBond IP address or DNS address, whatever you want. You will define the root certificate parameters. You would define the deployment type. Is it an on-prem solution or on-cloud solution or so? And you will upload the WAN edge list. Okay. So Cisco's portal will provide you a sample CSV or an Excel file, and you need to fill in the details of your WAN edges that are expected to become part of the SD-WAN fabric. Then you can fill in the serial numbers, the make and model, the model number of that particular WAN edge, right? The chassis number of the WAN edge and so on. And what you do, you upload that particular CSV or an Excel file over here in the while creating the organization profile. Once you upload all that detail, then the PNP portal will generate a serial file, and you can then download that serial file, right? After you download that serial file, mostly onto this admin machine, then you're going to log in into the vManager GUI and you are going to upload the serial file, right? That's one way. Otherwise, when you create an organization profile, instead of downloading it, you log in into vManager, or you log in with smart account in vManager directly to sync the information in the vManager. So either you manually upload it or you log in into the vManager portal using the Cisco Smart account, and it will automatically sync the information. That's how your vManager is going to know what all are the total advantages that are going to be part of the fabric. What's the organization name, what's the VBond IP, and so on. And the same information will be distributed by vManager to other controllers, so that vSmart also gets to know what all are the expected advantages to become part of the fabric, and VBond also gets to know what all are the expected advantages to become part of the fabric, right? And that's something that should be done. Post it, what's going to happen is the controllers now are aware about the advantages that are going to be part of the fabric. What about advantage? So advantage is configured with its factory default configuration that if it is not provided with any manual VBond IP details, or if it is not configured with the IP address of the VBond, then by default it goes to PNP Portal. The factory default configuration itself asks it to connect with PNP Portal. As soon as it discovers the internet reachability, it is going to talk to the PNP Portal. The PNP Portal is going to identify that this advantage belongs to some organization based on the chassis number and all that, and then it will reply with the VBond IP or DNS address to the advantage. So that's how, using plug and play, the advantage gets to know about the VBond's IP. Post that, as soon as you configure it and the certification process and everything is done, which we will discuss in the lab section, the advantage is going to speak with VBond that, hey VBond, let's form a DTLS tunnel or DTLS connection. Then VBond says, hey, okay, I identify you. My vManager have given me a list of advantage and I can see your chassis number and serial number in that particular list. So I authorize you to become part of the fabric. And here are your details about vManager and about vSmart. Which means VBond tells to your advantage that who is your vManager and who is your vSmart. Okay. You do not get to know about vManager and vSmart from anywhere else. Only your VBond can tell you about that. And upon successful authentication, VBond will distribute this information to you. Post that, Vantage is going to talk to vSmart, and Vantage is also going to talk to vManager that, hey, let's form DTLS tunnels. Once these DTLS tunnels of the Vantage is formed with all three controllers, that is when your WAN edge is onboarded. Until unless your WAN edge do not have these tunnels with the controllers, your WAN edge is not treated as onboarded. But as soon as it does so, then your WAN edge is completely onboarded and it's speaking with the controllers very well. So that's the role of orchestration plane. That's exactly why you do require orchestration plane to be there. If the orchestration plane is not there, then your VBond is not going to be onboarded at all. That's why orchestration plane or VBond is treated to be as one of the most important component in the SD-WAN or in the Cisco's SD-WAN fabric. I hope you understand that, and that's my bit about the orchestration plane, and I hope you enjoy the content as well. That completes discussions about your control plane, data plane, management plane, and orchestration plane. Entirely we are good with discussing and getting to know about the architecture and components of SD-WAN, of Cisco's SD-WAN. And then moving further in the next section, we will be speaking about how the control plane and data plane operations works by using one of the most important protocol, that is overlay management protocol, which is the Cisco's proprietary protocol for its SD-WAN solution. But that was all that we had to talk about in this session. Thank you so much for joining, and I'll see you in the next one. Take care. Bye-bye. Thank you.